Hi, this is Adam Griffin, and this is the second video for this week, sorry. And this is question 55, which is, the physics of circular motion sets an upper limit to the speed of human walking. If you take a few steps and watch what's happening, you'll see that your body pivots in circular motion over your forward foot as you bring your rear foot forward for your next step. As you do so, the normal force of the ground on your foot decreases and your body tries to lift off from the ground. So for part A of this question, a person's center of mass is very near the hips or at the top of the legs, and we have to model a person as a particle of mass at the top of a leg of length L. So we have to find an expression for the person's maximum walking speed, which is V max. So from our equations for centripetal acceleration and circular motion, we have our radial force, or net force in the r direction. The sum of that equals our mass, whatever our mass is, times velocity squared over L, or in the textbook it's r, but because our radius is the length of the leg, we can just put it as L. And then we can also set f of r equal to mg minus n, because gravity at the beginning of the motion is enough to start the motion, and that's enough to take over. So the normal force would be 0. So because we're like falling forward basically, so we don't need and well, we do, but it equals 0. So we can take that out of the equation, and then we have mass times gravity equals mass times velocity squared over L. So we can cancel that out, and now we have velocity squared equals gravity times the length of our leg. So we can take the square root of both sides, and we get an equation for our max walking speed, which is our max velocity equals the square root of gravity times the length of our leg. So now for part B, we will evaluate our expression for the maximum walking speed of a 70 kilogram person with a typical leg length of 70 centimeters. So we want to give our answer in meters per second and miles per hour, and then comment whether or not it's reasonable, and it tells us that a normal walking speed is about 3 miles per hour. So we have our equation right here. We can plug in gravity and our length, which is 70 centimeters, so 0.7 meters, and take the square root of that, and we get 2.62 meters per second. And then we can use some conversion factors. So to get it from meters per second to meters per hour, we just multiply it by 3600. And then to get it from meters per hour to miles per hour, we just use this. So now we have 5.86 miles per hour for our maximum walking speed. And while it's not 3, I can imagine that it is probably reasonable if you were trying really hard to walk very, very quickly. So kind of like a power walk. So I would say that that's reasonable. So for part A, we have our equation, and part B, our maximum speed for that person in meters per second and miles per hour. So that is the answer to 55, and thank you.